Welcome to Boat Physics, where the natural laws are anti-capitalist. Quick question. What the fuck? Follow-up question. How the fuck? The Dutchman weighs 426,740 kilograms, with 5,851 cubic meters of empty space. When the ship is underwater, that is, presumably, full of water, especially given the state of the crew. So that is 6,143,498 kilograms of water, making the ship 6,570,238 kilograms total. That would require a force of 64,388,328 newtons to lift. Who's doing that lifting? I guess the captain wishing really hard. But I have a different hypothesis. Like any God-fearing fish, the Flying Dutchman uses a swim bladder to rise and fall in the water column. Using electrolysis, a power any self-respecting God-adjacent entity worth their salt possesses, water can be split into oxygen and hydrogen gas. Using this absolutely canon ability, the Dutchman can be filled 62.5% full of air and rise to the top with an acceleration of 1 meter per second squared. Once it has resurfaced and the bilge has been pumped, the ship has a buoyancy force of 3,733,974 newtons, displacing 381 cubic meters of water. Now let's look at the physics of the act of sailing. There are many forces at play on sailboats. There's the gravitational force of the boat, as well as the gravitational force of the sailors, who move around and affect the balance of the boat. This is nearly negligible on tall ships like the Dutchman. There is the force of the wind and the force of the sails, the force of water on the keel and the drag force of water on the rest of the hull. Drag is like friction, but for objects moving through fluids. Drag force increases as the speed of the boat increases. This means that as the velocity of the boat increases, acceleration decreases. Those example values are from the Lady Washington, which I use in the director's cut to compare the Black Pearl to a real-life ship, but I ran out of time to include it in this video. Lifting force is when the angle of a wing causes an increase in pressure beneath it and a decrease in pressure above it, causing the wing to lift. With sailing, the wings are vertical. The sail cuts through the wind and curves in such a way that an increase of pressure is created at the back of the sail, and a decrease in pressure forms at the front of the sail. So the sail, and thus the boat, is pushed and pulled forward in the leeward direction. While this occurs, the wind also pushes the sailboat over towards the horizontal. That's where the keel, or centerboard, comes in. As the boat is rotated around the heeling moment, the keel pushes back on the water, simultaneously keeping the boat from capsizing and creating another pressure differential, which pushes the boat in the windward direction, allowing the vessel to move forward instead of sideways. Hull speed is the maximum speed a boat can travel while still running efficiently. To find it, you take the square root of the boat's length at the waterline and multiply it by 1.35. This is theoretical, but there are many ways boat builders and sailors can increase a boat's hull speed. I get into all of that in the director's cut of this video, available on YouTube. It has to do with the length of the wave created when the hull cuts through the water. If the Black Pearl's length at the waterline is 160 feet, her theoretical hull speed is 19.505 miles per hour, or 8.72 meters per second. Also, fun fact, don't look it up, the Black Pearl has no drag in the water. That's why the Pearl is nigh uncatchable. She has no drag in the water because Jack sold his soul in exchange for Davy Jones raising her from the depths. This ship is undead and has been resurrected more times than Jesus, so why would her hull have any drag? That's the real reason why the Royal Navy and the East India Trading Company are angry at the pirates. All the colonization and slave trading in the world can't buy hulls with negligible friction. This shot of her hull, all covered in barnacles, is capitalist propaganda by Disney and the East India Company, shoehorned into a socialist film. This also has the completely coincidental benefit of my not needing to factor in a change in acceleration when calculating the Pearl's kinematics. When running directly downwind, the wind blows into the square-rigged sails directly from behind. One would assume. I don't know how to sail tall ships. I'm going based on the knowledge that square-rigged sails were designed for running for weeks at a time with the trade winds, and if you angle off the wind, you'd eventually leave the trade wind latitudes. I digress. On the Black Pearl, the square rigging going directly downwind have a total surface area of just under 395 meters squared. When true wind is blowing 10 meters per second, or 22.4 miles per hour, the pressure difference adds 22,678 newtons of lifting force, creating a net force on the ship of 45,356 newtons and 0.1116 meters per second squared of acceleration, allowing the ship to reach hull speed in 1 minute and 18 seconds. For both beam reach and close haul, the Pearl has to use her staysails and lateen to cut through the wind. These have a total surface area of just under 399 meters squared. The pressure difference with the sails cutting through 10 meter per second wind gives the Pearl 22,881 newtons of lifting force. This comes to a net force of 45,763 newtons and an acceleration of 0.1126 meters per second squared, allowing the ship to reach hull speed in 1 minute and 17 seconds. The most common sail setup to see in the Pirates films is a broad reach. This is when the wind is coming off the stern quarter and hits the sails at an angle that allows all sails to be up. This happens to be the coolest look, so it makes one wonder, perhaps there's some oracular wind god in the Pirates of the Caribbean universe who lives for the drama. Considering the loose use of Greek mythology in these films, my money is on the bisexual icon Zephyrus. He sees something interesting coming and pushes the wind around behind them so it can happen under aesthetically pleasing sail power. The broad reach also gives a total sail area of a whopping 868 meters squared. The pressure difference adds a lifting force of 49,827 newtons. This creates a net force of 99,654 newtons and an acceleration of 0.2452 meters per second squared, allowing the ship to reach hull speed in 35.6 seconds. The square-rigged sails of the Pirates of the Caribbean ships are limited to 45 degrees off the wind. So look at this bullshit. These motherfuckers are sailing directly at each other with all their square sails down. Based on the angles of the sails, these are the directions the external forces propelling the ships are coming from. So what are those external forces? I think that in addition to wind, the Pirates of the Caribbean universe has another natural force, strong enough to propel ships. The epic music of Klaus Badelt and arrangement of Hans Zimmer. Doesn't that get you pumped up? I propose that music is a natural feature of the environment in the Pirates of the Caribbean cinematic universe, like wind, possibly brought about by the structures of the molecules in the atmosphere. Impossible for us to test, and impossible to disprove. Starting here at an initial velocity of 4.37 meters per second, the Pearl seems to move a very roughly estimated 200 meters to reach a final velocity of 5.81 meters per second. The calculated acceleration is 0.04 meters per second squared, and the time it takes is 39.3 seconds. The sound force calculated to be pushing on the sails is 14,894 newtons, with a sound intensity of 87.4 watts per meter squared. That translates to 139.4 decibels, which is approximately the sound of a jet engine taking off. For reference, exposure to 130 decibels of sound would cause instant damage to our eardrums. The maximum energy a normal human eardrum can withstand in 39.3 seconds is 0.04 joules, with an intensity of 10 watts per meter squared. The energy on the eardrums in this scene over the 40-second period is 0.34 joules, and no one seems bothered by the noise. No one seems bothered by the sound of any explosions in these movies, which proves my point. Look at this. Yeah, he's in shock, but I have experience with both cannons and guns, and in addition to knowing that a single gunshot is about 160 decibels, I can tell you anecdotally that none of his cadre would be able to hear his little whispered mantra because their tympanic membranes would be destroyed. Their ability to hear him is a testament to the fact that they have naturally much stronger eardrums than us. Let's say their tympanic membrane can withstand 0.5 joules of energy in a 40-second period. That means their ears can tolerate a sound intensity of 125 watts per meter squared, which is 115 more than we can. The fact that the ships in the Pirates of the Caribbean cinematic universe can move with the sound waves of the diegetic music makes me open to the idea that Davy Jones, taking up so much space on his ship with a pipe organ, is actually quite practical. The sound waves he generates playing his obsessive octopodic oratorio make their way out to the rigging and give the Dutchman an extra boost. Will better learn to play the piano or they'll be in for a world of boredom if they ever get stuck in the doldrums, when the wind and music dies. I hope he got some piano workbooks textbooks on his one day ashore because 10 years of plinking it out with no instruction does not sound fun. Anyways, thanks for watching Boat Physics. I hope it was simultaneously informative and superfluous.